Hey, it's still sharing the slide, right, guys?
Yeah.
Yeah.
Okay, good.
Dave, do you see where is the chat area? Because I just see Q&A.
Yeah, that's all I see too. I'm not sure that there is a chat. That's probably disabled. Is that right, Carolyn?
Well, that's what I'm looking at right now because I'm seeing the same thing, and I just asked Corinna the same question. So we're just going to go with Q&A. So if anyone has any questions or comments, they'll do it through the Q&A.
Okay.
All right, it's 11:30. Should we start?
Yes, absolutely.
All right, are we live now, Carolyn? We can get started?
Yes, you may.
All right, wonderful. Welcome, everyone. My name is Dave Petrucci. I'm a safety engineer with the Federal Highway Administration's Resource Center, and it's a pleasure to be with all of you today in our virtual workshop here on the use of the Interactive Highway Safety Design Model, IHSDM's Crash Prediction Module, and how it can be applied in the context of traffic impact analyses. So this is my first time doing a Zoom course like this. So if I make a mistake or if my fellow presenters make a little bit of a goof here or there in Zoom, please forgive us. But it's a pleasure to be with all of you. Thanks for taking time out of your schedules. And I hope this is a great kickoff to a terrific conference. And I know it's a little bit different this year. Probably not having to worry about the snow this year in State College, but hey, at least we can get together and be with our greater professional family using these virtual platforms. So without further ado, I'd like to get into our workshop. We're going to do our best, everyone, to have this be interactive. It's going to be pretty dry, pretty fast if we don't get some feedback from all of you. That's what I think will really help move this along and make it interesting and valuable, worth your time. We'll prompt you for some information throughout the workshop via some poll questions. So get ready. We're going to put you on the spot and ask you to respond to those poll questions. But there's also a question and answer pod where you can pose questions along the way. So please, at any moment, if you have a question, a comment, an observation, something you'd like to share, please do that. There is not a general chat pod, but instead we're going to be handling that kind of feedback and interaction using the Q&A pod. So without further ado, I am sharing the presentation that we'd like to go through, and hopefully you can see that, okay? And the audio is coming through all right as well. If anyone has any audio or connection issues, please do reach out. Let us know as well in the Q&A pod. So without further ado, as a employee of the federal government, I am required to issue a disclaimer ahead of our remarks today. If we happen to make mention of any particular commercial products, that's not an endorsement. It's just because it's germane to the discussion, the material at hand. So that's why. And the information that we're presenting to you today is the compilation of some recent work from our team, and we hope that it's helpful to you in a topic that I think is somewhat new, and that is incorporating data-driven safety analysis or safety analysis in general into the world of transportation impact studies. So we have an agenda to work from. We'd like to provide some introductions, not among all of the attendees. We weren't quite sure how to pull that off. Instead, there are some opening comments that we'd like to cover. Then we'd like to briefly discuss the capabilities of IHSDM and an overview of the applicable parts of the AASHTO Highway Safety Manual, that is Part C. Specifically, we'd like to cover the crash prediction module's capabilities and some issues that are accompanying the use of the crash prediction module of IHSDM. Then we'll get into a case study based on what's available in a relatively new guide that I'll also get into in a bit. And that's going to be the focus, I think, of some of our analytical work while we're together today in this workshop. I'd like to do a bit of a demonstration, and then we will summarize some of the results from that project and then wrap things up. That's the game plan, everyone. I hope that sounds like what you were expecting today. And we're only together for now a little less than an hour and a half before we transition onto the conference or other things that we have to get to. So let's jump right into it. So with that, I mentioned some poll questions. This is the first one. We need you to participate. We need you to let us know who you are. So if you'd be so kind, please let us know your employer type, your organization that you represent, where you're coming from. That would be wonderful. And we'll keep this poll open for the next 10 or so seconds. I realize that you might not have all clicked the button yet, but let us know who you are. All right, let's close this poll. Carolyn, assuming we've got good interaction, if we could see the results, that would be great. All right, we have several of us that are coming from consulting firms and a few of us from state government and planning organizations and a couple others that may be a couple of the feds that are here in the room. So, all right, most of you are consultants. All right, that's great to know. So my name again is Dave Petrucci. I'm a safety engineer with the Federal Highway Administration's Resource Center. I've been with the Resource Center for more than 6 years now, and I specialize on our team in data-driven safety analysis, intersection safety, alternative intersections. And I come to Federal Highway with a background in consulting, and I worked and lived mostly in the Mid-Atlantic area in Pennsylvania. And I specialized then in a lot of traffic operations work. Intersection design, traffic impact studies was one of the things that I spent a lot of time in reviewing them and preparing them. So this is a topic that I'm pretty excited about. And it's a pleasure to be back with everyone as part of the conference today. My partners in crime, fellow presenters, are Mike and Asan. And I guess in the order that we have you guys on the slide, even though Asan's going to go after me after my remarks, I was hoping that Mike and Asan could introduce themselves as well. Mike? Mike, you may be on mute.
Hello, everyone. Yeah, this is Mike Demuta. I'm really glad to be joining you today and looking forward to it. Thanks, Dave.
Hey, thanks. Asan.
Good morning, everyone. I'm also very glad to be part of this. Hopefully, we will have a very informative session. Thank you.
Great. Thank you, guys. We're going to get into the PowerPoint and the material here, but I do have another poll question for you. We'd like to ask you right now, based on your experience, your perspectives, and whoever you would consider a stakeholder in the world of traffic impact studies, how does safety rate? On a scale of 1 to 5, 1 not being important at all, and 5 being very important, please rate the relative importance of road safety to the myriad of stakeholders involved in traffic or transportation impact analysis. Please participate in this poll. That would be great. All right, Carolyn, if we're getting good responses from our 35 plus attendees here, please participate, everybody. Let us know what you think, and unbiased. We don't want to lead you in any answer here. So who knows who our stakeholder is? It depends on your opinion there. Let us know the results. If you could share those with us, Carolyn, that would be great. All right, so here's the response. No one said it's unimportant or not particularly valuable, but it looks like the lion's share said safety, road safety is very important or somewhat important. All right, so we've got 35 of you here and 31 of you said somewhat or very important. That's great. Thank you for participating in that poll. So I'd like to cover some introductory items here as we get into things. So what do I mean by data-driven safety analysis and how it can be part of our lives using IHSDM? DDSA is the application of the latest evidence-based tools. It's meant to provide a reliable estimate that we can use to examine existing and proposed safety performance. And data-driven safety analysis, it's not just, say, the Highway Safety Manual Part C. It really is meant to be reactive and proactive applications of both predictive and systemic safety. And it's pretty safe to say within the profession, we're seeing an evolution from nominal safety, just saying whether or not a standard is met or some condition exists, yay or nay, a very binary type approach. Did we meet the warrant? Yes or no? Did we exceed or fall beneath the average crash rate? These yes or no type questions, that's nominal safety. We're really seeing an evolution where we are going to substantive approaches, where we derive performance measures for safety, similar to the way that we have been deriving them for operations. And hopefully DDSA can be a method through which we quantify impacts of any transportation investment decision. And so that's the vision. The vision would be that data-driven safety analysis and safety performance on the whole is considered in all of our investment decisions. Now, what do we mean by traffic impact studies? And I know that many of you have a whole ton of experience in traffic impact studies. Depending on where you are in the country, there's going to be a very different definition, different rules all over the place. There's a lot of terminology being used, but generally, these are studies where planning level techniques and engineering come together to estimate the impacts because of some change. Some generator is doing something to the surrounding transportation system when it comes to access and exposure. And requirements for these studies vary, but typically they can be found in local ordinances and DOT guidance. But traditionally, they have a limited focus. Traffic impact studies focus in on motor vehicle operations and measure what happens if you increase volume, move volume, decrease volume, i.e. change exposure. And in some cases, there are assumptions that what we do to mitigate quote unquote operational impacts may also have some direct safety benefit. That's an assumption perhaps that might work in some cases and might not in other, but we do know in many cases throughout the nation that nominal safety approaches are what are used through traditional traffic impact studies. So this means we have some challenges with the traditional approach. We're typically only focusing on predictive tools being employed for operations, but now for the past 10 years, we've effectively had them for safety. The study areas for these documents are limited and typically only are looking at nearby or adjacent intersections, and rarely do you ever see a traffic impact study talk about off-peak performance later at night, earlier in the morning, in the midday. Seldom do you see that. And one of the assumptions, the operative assumptions, is that the high volume time periods are the time periods that we should be talking about, that they are representative of the problems and the challenges facing our study areas. Is that always true? Existing crash trends also are in many cases used to understand future safety issues. We pull crash data, we stick them in reports, we see tables at times, but then that information is used to understand the future with and without a proposed generator in place. Mitigation, though, is limited, and usually it's the result of negotiations, some defined threshold for impact, but it can be expensive, especially if you're talking about mitigating delay and widening highways, building new intersections, signalizing something. And they can be rather expensive and tend to be limited. So these capacity adding improvements may end up being somewhat challenging. However, another particular challenge with traditional traffic impact studies are that many of the outcomes, some of the outcomes we know are associated with reduced safety performance. In other words, the latest science would tell us that certain actions or outcomes from traffic impact studies would increase crashes or change severity for the worst. So I have a slide here that's meant to hammer home this point. While there are some challenges, and it's not going to be easy, we do know that there's a lot in common between safety analysis and what we're already doing traditionally in traffic impact studies. Both involve selecting a study area and exploring performance for existing and future scenarios. Both traffic impact studies and DDSA share inputs. HCM inputs and HSM inputs could be the same, and both use traffic volumes as the primary way to measure things. And I'll also say that it's true that both do emphasize the role and importance of calibration, garbage in, garbage out, and safety analysis and capacity analysis both rely on strong calibration. Whether or not that happens is another whole entire question. So another important point is that whether safety analysis is done in an impact study or not, decision makers have value, and the public at large value both operations and safety. They tend to look at things, our customers would look at things perhaps from a focus of just say operations, from perspective both operations and safety. And because they calculate and collect some of the same information, there might be an opportunity here to leverage success in one domain for the next. So Federal Highway put out a how-to guide earlier in 2020, and this how-to guide explains some of the linkages between the traditional impact study and DDSA. If you haven't seen this guide before, check it out. It's available on the web. You can Google for it, but it's very limited. It focuses on just a demonstration that we'll use today, showing what safety analysis can look like inside of an impact study. So specifically, if a traditional TIA looks like this process here, where we have some development that comes into some existing area and growth and changes in the future have to be anticipated, and then we analyze all of those changes. We have a guide here that suggests there are opportunities in all of these stages of TIA development to better infuse safety and to incorporate data-driven safety analysis, from evaluating vulnerable road users and pedestrian care facilities within a study area, all the way through performing safety analysis for the same scenarios that we would tend to investigate inside of operations. So that's my opening set of remarks. I hope that's helpful in setting the stage for you. And with this, I'm going to pass the baton over to my colleague, Ahsan, who's going to provide an overview here. Ahsan, you have the floor, sir. You may be muted, Ahsan.
Thank you, Dave. Yeah, thank you. So, okay. So thank you. So let me go over the IHSDM and also HSM Part C overview. So the IHSDM version 16 recently released September 2020, and also Highway Safety Manual, the first edition published in 2010. As Dave mentioned, let's keep it interactive. So Carolyn, could you please bring the poll number 3 up? So let's see what's your level of experience using the IHSDM. hopefully we get good number of responses. So I think probably we can close the poll and see the result. So yeah, based on what I see, okay, have never downloaded or used IHSDM. So there is a kind of good opportunity for us to present and demonstrate IHSDM. So let's go to the next slide. And there is another poll, but let's look at the more general perspective. So Karen, could you please bring poll number 4? So this is for Highway Safety Manual Part C. So what's your level of experience using HSM, especially Part C, which is predictive method? I think it's enough. So probably we can close the poll and see. Okay, so here is a little bit more diverse. So we have some folks extremely familiar and use Part C, but also on the other hand, we have some people didn't use Part C or IHSDM, and someone who mentioned what's the HSM. So I will try to go over the basics in the following slide. So before that, let me introduce the IHSDM development team. So our Federal Highway Geometric Design Lab Manager, Clayton Chen, then Mike DiMiuta and I are the GDL staff, and then our IHSDM software developer, Pete Holm, and on the Federal Highway Resource Center, Dave Petrucci, and also Office of Safety, Jerry Rogi. So IHSDM currently covers 5 different modules. So 2 modules are based on 2 IHSDO important documents. So on the left-hand side, Highway Safety Manual, which actually the crash prediction module of the IHSDM is based on that. And then economic analysis tool can be used based on the results of the CPM. And then based on the Green Book, we do have the policy review module. So using these 2 modules, you can do evaluations. Also, we do have some diagnostic tools, traffic analysis module, design consistency module, and driver vehicle module. So these 5 modules can be used for different kind of evaluations. So Highway Safety Manual, published in 2010, the first edition, and it does have 3 volumes. Volume 1 includes some introduction and fundamentals, and part B of the volume 1 includes roadway safety management process, which there is an associated tool with that part, which can implement the methodology, IHSDO safety analyst. But then volume 2 has the part C, predictive methods for different facility types, which I will explain in the next slides. There are many tools that can be used to use this predictive methodology. IHSDM is one of them. And also the volume 3 covers around 500 selected crash modification factors. But back then in 2010, there was a selection criteria, but on the CMF clearinghouse, currently there are near 7,000 CMFs. Not all of them are good, but there are a quality rating that can help to select one of them. And HSM Part C, the first edition covered roadway segments and also intersections for 3 different area type. And Chapter 10 was on rural 2-lane highways, Chapter 11 rural multi-lane, and Chapter 12 urban and suburban arterials, but with 5 lanes or fewer. But the supplement to first edition published in 2014, and the models covered freeway segments and freeway speed change lane area, and also freeway interchanges, ramps, and also ramp terminals. So some basic about the facility types. As I mentioned, there are many different facility types. So therefore, there are different models, the different data needs, and also the design element, the factors that were considered depending on when the models were developed, depending on the available data to the researchers. So they vary significantly facility to facility. And also models are available for different crash types. So for example, for some of them are for total crashes, but some of them are specific for multi-vehicle, single vehicle, or intersection related or driveway related. And also they cover different severity levels. Some are for, again, total, FI, and also FI refers to fatal and injury, and then PDO, property damage only. But then again, they are different facility by facility. But the general model form is like this function. So let's review each of them. So the predicted crashes are equal to the safety performance function prediction, which is NSPF. So this is a regression equation, but it's for kind of the terminology is base condition. So for example, the model was developed for a rural highway with lane width 12. So as one of the base condition, and also some other geometric or other characteristics. For example, if light was present or absent. So the prediction here is just based on base condition, but for the differences from base condition to the site location. So let's say lane width instead of 12 is 11. So for those differences, there are a series of the crash modification factors depending on the facility types that can adjust to the site characteristics. But then since these models developed from certain states or for a different time period, let's say from Washington and California, and also for, let's say, kind of long time ago. So for temporal and spatial calibration, there is a need to develop a local calibration factor if the models are going to be used in a jurisdiction different from those that they were developed. Or another method is to develop this kind of safety performance function and crash modification factors by the jurisdiction. There is also another component, which empirical based process. If there are historical crash data available, these predictions can be improved or kind of toward the expected crashes rather than predicted. So the idea is so having a weighted approach to combine the prediction from models with the observed crashes from historical data. So the expected crashes based on this methodology is always between the observed and predicted crashes. So this is kind of pooling the expected crashes toward the mean between these two. So, but it's not exact mean. So depending on what's the value of the W, which actually is based on the quality of the prediction model, then it's a weighted average between these two. So let's have another poll question. So what tools or methodologies do you use for crash prediction? Please select all that applies. I think we can close this one as well. Hopefully we have good responses. And yes, so yeah, highway safety manual 68% interesting, and then part C spreadsheets, in-house spreadsheets, ISAT, safety analyst, and 3 people responded IHSDM. So hopefully these numbers are going to change. So, okay, for using IHSDM, the general workflow is always starting with creating a project. So, and then adding highways or intersections, interchanges, or inputting other kind of data, like if historical crash data available, adding them, and then depending on the selected module, then running the evaluation, and then viewing the output results, which for certain cases, they can be also used in other part of IHSDM. For example, the crash prediction results can be used for economic analysis. And then in the DDSA, the crash prediction module of the IHSDM can be handy, and in the following slides, Mike is going to explain about them. Thank you.
Thank you, Hassan. And I'm just going to share my screen. Okay, so Hassan gave an overview of these methods in general. So now we're going to talk about the IHSDM capabilities specifically. And of course, you just participated in a poll question. You see there are multiple tools that can be used. Each tool has certain limitations, certain advantages or strengths. Here with IHSDM, as with some of the other tools, the one advantage is that IHSDM includes a faithful implementation of all of the first edition HSM Part C predictive methods, including the calibration utility, which is part of the what Hassan just mentioned, and the empirical Bayes method to factor in historical crash data. So beyond just covering the first edition HSM, there have also been additional models for certain facility types that have been produced under NCHRP projects with the intent that these methods would be included in the second edition HSM, in the future HSM second edition. So IHSDM already includes models for 6+ lane and one-way urban and suburban arterials. Those were developed under NCHRP Project 17-58, and also models for roundabouts, which were developed under NCHRP 1770 and documented in a report, NCHRP 888. So those are an extension of what's currently in the HSM. User-defined crash modification factors. This is something that we'll talk about more in a minute, and then we'll show in terms of our demonstration. You'll see this come into play, but this gives the ability to go beyond what's in the HSM Part C methods by having users define these crash modification factors as needed. Also, the ability to enter agency-specific models or distribution data, and there are some limitations to that. What this means is if an agency, let's say PennDOT, has developed their own safety performance functions, if they're in the same functional form as the highway safety manual models, they would be able to enter those into IHSDM and to use their models rather than the default highway safety manual models. Also, there are crash distributions that are listed in the highway safety manual, such as a breakdown of different crash types and so on. And those, if the state has better information than what's in the safety manual, they can input that in IHSDM. There are two options for data input and analysis, and we'll touch on both of these. We'll demonstrate both of these to you. Location-based has a big advantage. For those of you who have used HSM Part C, you know that segmentation is a key component, and that means that in order to do the evaluations, we're essentially broken down, the model is breaking down into sites or homogeneous segments, or intersections, or ramp terminals, which would be also considered sites. But for segments, based on the changes in crash modification factors, based on anything that would affect the results, the homogeneous sections need to be created, and then those are evaluated individually. With location-based input, the software will automatically do the segmentation for the user, whereas in site-based data input, it's more like a spreadsheet type tool, which is fine, and it's sometimes easier to input the data and to run an analysis using the site-based data. The downside of that is that the user would have to know how to do the segmentation and then base their sites on what they've already segmented. So one, location-based does it automatically. Site-based, the user needs to know how to do it. Another advantage of this location-based data input is that it can model the network connectivity, so that, let's say if you have a project that includes a freeway and the interchanges and a local network with arterials and intersections, ramp terminals, that the location-based data, because of the way that it's structured, has that connectivity. So it knows that these different pieces are related to each other. And that includes the ability to have a graphical display in what we call the highway viewer. Also importantly, and again, we'll focus on this as part of this workshop, there is an economic analyses tool which uses crash prediction module evaluation results as input. So let's talk about user-defined CMFs a little more. So what are they and why are they needed? Well, the HSM Part C models cover a wide range of facility types and scenarios, but certainly not all. And in many projects, the scenarios don't fit neatly within the bounds of the HSM Part C method. So for instance, the models are only applicable for urban freeways less than or equal to 10 lanes. So if you have a 12-lane facility, technically those models do not apply to that facility. So what do we do? Also, many pedestrian treatments, countermeasures that are intended to reduce pedestrian vehicle crashes. Many of those methods, those countermeasures are not represented in the Part C models. So how do we, if we're implementing one or more of those, how do we account for the safety effect? Well, HSM Part C lists 4 methods for estimating safety effectiveness of a proposed project. Method 1 would be when everything fits nicely within the Part C methods, so you just apply those methods, and that's always preferable. That's the best case. But if that's not possible, again, if you have an urban freeway that's 12 lanes, or you have pedestrian countermeasures that are not in the models, then the next step would be to look for crash modification factors that would help to account for the things that are not represented in the Part C models. So in IHSDM, we've added these user-defined CMFs, which would allow, so if on your project, if you've identified one or more crash modification factors that would you want to apply to the HSM Part C results that you're getting from IHSDM, it allows you to define those. So we can call those either external CMFs. We call them user-defined CMFs here. They are data elements in the data editors, and again, you'll see that in a few minutes when we do a demonstration. So for each facility type, if you have a highway or an intersection or whatever it might be, you have the ability to define these CMFs, and also to indicate what type of, do they apply to a certain facility type, what type of crash severities do they apply to? Do they apply to total crashes, just fatal and injury crashes, only property damage only? So again, this capability supports HSM Method 2. And at the bottom of the screen, you see a table which shows what example of what it looks like in the interface. So we have 3 user-defined CMFs there, one applied to total, one to PDO, one to FI, and the CMF values are in the red box on the right side, showing those values. Let's talk a little bit about economic analyses. Very important when we're talking about looking at a safety analysis in terms of traffic impact analysis. So we want to get to the point where we can evaluate the economic benefits or disbenefits of different alternatives. So first, I want to briefly just talk about economic analyses in general, and then to talk about the IHSDM tool specifically. When we talk about benefits, so if we're doing a benefit cost analysis, when we talk about benefits in this context, we're talking about essentially the benefits of reducing crashes compared to some sort of base condition, could be a no build, could be the existing. And then assigning, so if we for reducing crashes, then we need to have crash costs for each type of crash, each severity, based on severity levels, to determine what the reduction in crash costs are for that safety improvement project. And these crash costs are also often used as part of network screening to try to identify locations that have the highest potential for safety improvement by reducing potential reductions in crash costs. When we talk about crash costs, again, in this context, and this also comes from, you see at the bottom of the screen, it's from Crash Costs for Highway Safety Analysis publication that FHWA put out a few years ago. The comprehensive crash costs, or sometimes called societal crash costs, the combination of the tangible impacts, so the economic costs of the crash, plus monetized pain and suffering. So these costs are meant to capture all of the impacts that result from crashes. Some of you may be familiar with what's called the KABCO or KABCO scale. Again, in the FHWA guide, there are recommended crash costs assigned to each one of those severity levels. So for K crashes, which relate to fatal crashes that result in fatalities, the recommended crash cost is a little over $11 million per crash. As we go down through the other levels of less severe, suspected serious injury, and then suspected minor injury, possible injury, and no apparent injury, which is similar to property damage only. You see the costs drop down. No apparent injury is just a little under $12,000 for a crash. So if we know for a given scenario, if we know how many crashes are expected in each one of these categories, then we can multiply those by the crash costs, the unit crash costs, to get our total cost. Okay, so in IHSDM, the economic analysis tool allows users to do this type of analysis using the crash prediction module evaluation results, meaning the crash frequencies and severities. So take the results from the models as Ehsan had described, and then break those down by severity, assign the crash costs, and the end result is that we have a basis to compare in dollar amounts, compare different alternatives. So the scope is that it does apply to all facility types that are currently covered in the crash prediction module, meaning all of those facility types covered in the HSM first edition, plus the urban arterials that have 6+ lanes and also one-way arterials, roundabouts, and so on. So it covers pretty much everything that's in the crash prediction module. In terms of output, the main output currently is benefit cost analysis. Again, when we're talking about benefits, we're looking at what's the crash cost reduction of an alternative case as compared to the base case. And these are net present values. So let's say if you have a project that's over, say, a design life of 20 years, then what this tool would do is to look at the benefits year by year and then bring those back to the present, so net present value. The costs, meaning initial construction costs, maintenance costs, those are not calculated by the software, but the user would input those. So they give their best estimate of those costs. And from there, benefit cost ratios and present value of net benefits would be determined. So with that, I'm going to turn it over to Ehsan to talk about a case study that will involve some of these tools.
Thank you, Mike. So let's see the case study in the how-to guide, which is trying to integrate the TIA with the DDSA. So there is a proposed new development, a pharmacy on the corner of a signalized urban intersection within a moderately developed area. So on the capacity side, there are some simulation tools and other actually methodologies to actually compare different scenarios. But How about the potential safety impacts of having a new development? So let's review this new development together. So there is a company X is proposing to develop a pharmacy with a drive-through on the northwest corner of that signalized intersection. And the site can be accessed via the west leg of the existing traffic signal, and the development is being proposed across the street from a large existing residential area. So there are 3 years of historical crash data available for 2015 up to 2017. And there were 22 crashes with actually identified as related to this intersection. So let's review them again. So 22 crashes, 17 property damage, 5 FI, and rear end crashes were the most, followed by sideswipe, and there were no back plates on the signal heads, and the left turn movements on eastbound, westbound are permissive only currently, and right turns on red were allowed. So the pedestrian facility, there are no pedestrian facilities provided and no sidewalk. However, it was observed pedestrians were crossing all 4 legs of the current intersection. And however, there were no pedestrian related crashes in the past 3 years prior to this analysis. And overhead lighting was not present at the intersection, but the existing commercial and corridor lighting was available. So considering this development is going to be constructed to address the safety issues, the alternative one was installation of the backplates on signal heads and also some pedestrian facility like curb ramps, pedestrian signals across the north and south legs of the intersection. And also another treatment was optimizing the signal timing. But for the alternative 2, let's have all that were included in alternative 1, backplates and also some pedestrian facilities and optimizing signal timing, and then also doing some geometric design changes like installation of a southbound right turn lane, and also again lane geometry conversion on eastbound and westbound to allow the actually protected permitted left turn movements. So to apply these changes, for some of them, the Highway Safety Manual Part C does not have a CMF. So as Mike mentioned, there are some CMFs that can be incorporated in the process as method 2. So for example, for installation of crosswalk, they look at the available CMFs from CMF clearinghouse, but the CMF was 2-star from the 1 to 5-star quality rating. So they decided eventually not to use them. But then for installation of pedestrian countdown timer and also backplates, they found some relatively good 3-star and 4-star, and they decided to use this for this facility and improvement. But also for optimizing signal, they couldn't find the CMF, so it will not be included in the analysis. And for those 2 CMFs, they came up with a composite CMF 0.78, which will be used for the safety analysis and also in the IHSDM. So after this brief introduction, I will pass again to Mike for a kind of IHSDM demonstration.
Thanks, Eston. I'll go ahead and share my screen. So right now you should be seeing the IHSDM interface. And as we saw from the poll results, very few of you are familiar with this. I'll give just a very brief introduction to the interface, and then we'll get into the meat of this case study. So what you're seeing on the left side is the what we call our hierarchical data structure. So we have the top level represents a project, and a project is essentially a container for all the information, highways, intersections, whatever other entities you might have that you would like to evaluate. So the subnodes here, like Main Street and Smith Road, existing, and also we have the build conditions. So those are highways. And then we have an intersection that's, in this case, it's created, it's the intersection of Main Street and Smith Road. So there's the intersection. And then once we'd like to evaluate those, we can run evaluations, and then these are evaluation nodes underneath. So we have project, highway, intersection, and evaluation. So again, here's our case study project that Ehsan just introduced. Let's go ahead and take a look at, he showed you the sort of photo, what it looks like. And so the existing in IHSDM kind of looks like this. And so here are our two highways, our Main Street, here's Main Street, and then our Smith Road. If we zoom in on this, we can see that the viewer actually, you know, it's not a CAD product. It's not tended to be extremely detailed, but it does show the different number of lanes. So we can see here on this particular leg, we have 3 lanes, including a left turn lane. See, we have 3 lanes here, 4 here, so on. So that's our existing highway. We also, again, keep in mind here we have the 3 lanes. Let's take a look at our build condition. This is alternative 2, right? Where one of the things that was done was to add an additional right turn lane. So here's where we had 3 lanes here before. Now we have 4. Okay, so where does this data come from? Where am I? How is it displaying this? And that's in our what we call highway editors. So here I've just opened up the highway editor for the existing Main Street. So there are different data elements here. Now, earlier I mentioned location-based data input versus site-based data input. Everything we're looking at here, this top part, this interface, this editor, everything down to here, that's all location-based. So, and what that means is that, say here we're entering lane data, that we would enter a start and end location for each lane. Okay, so here this first one is a through lane, starts from station 0, ends at station 10. We have the lane width, start, end, tell what kind of lane it is, it's left turn lane, through lane, or so on. As you'll see later, these here at the bottom are site sets. So these represent site-based data. And Ehsan will talk to you a little bit about that later. But I'm going to focus on our location-based. So here, as you see, we have, in terms of the lanes, we have through lanes identified. We have the right turn lane, left turn lanes. We also have ADTs entered for year 2017 as well as 2020. Have a median value here is just a 4-foot width. Also, I want to show you the crash data. So we do have existing crash data, and there were 22 crashes between 2015 and 2017. So these are represented in, those crashes represented in this table. So that includes the year, the severity, you know, is it fatal or injury crash? Is it a property damage only? The type of crash, here we have these are all multi-vehicle crashes. Where it, so that these occurred at the intersection, so the location is all the same. And then it's noted whether the crash is intersection related or not. So with this study, everything, we're just looking at the intersection. So all of our crashes were intersection related. Here's where later on we'll look at the user-defined CMF. So here's where we would add it. Right now there are none here, but I'll go ahead later and add the user-defined CMF to represent the countermeasures that are not represented in the HSM Part C models, as Ehsan described. Okay, so that's taking just a brief look at the highway editor. So again, we have our highway editor, which contains all the data. We have the highway viewer, which allows us to see that data displayed, which is all fine and good. But of course, the main thing is that we like to evaluate those. So in this case, well, we were looking at highway here just as an example. We also have intersection editors. So here's the intersection of our two highways. Okay, same thing that we saw in our highway viewer, but this interface provides the same way that the highway editor provided a means to enter, display, edit the data related to the highway. This does the same, but for the intersection. So we have some basic features, characteristics of the intersection here, like traffic control. You know, is it signalized, stop controlled, or so on. So this is a signalized intersection. And then different things related to crash modification factors in the model. Some of these are related to the pedestrian models, whether there's a school nearby or there are bus stops, number of alcohol sales establishments. These are factors that are represented in the vehicle pedestrian crash model for signalized intersections. Okay, so only the data that's required to perform these evaluations would be shown here. One thing I'd like to bring your attention to is the left turn phasing. As you notice, for Smith Road, the left turn phasing is currently permissive. Okay, so the two legs have a permissive turn phasing. That's something that you might recall from what Ehsan described. That's one of the improvements, was to make some changes to the lanes so that these could be converted to protected permissive. Okay, so right now we're just looking at the existing pedestrian volumes, so on. Okay, so this is representing our existing case. So now that we have all of our data input, we can go ahead and close this, and we're going to run an evaluation. Okay, so we have our intersection, we have all of our data input, we have the crash, historical crash data input. I've already run these, but I'm going to rerun this just to show you how the interface looks. So here's this is run on the existing condition. So the future build, but it's the existing with no additional site traffic. So no additional traffic from the proposed development. So what does that look like? Let's go ahead and rerun that. So we're able to provide an evaluation title. In this case, evaluation 24 was just the next one in line, so I'll keep that. We can put in a description if we want. If we have calibration factors input for model, we can point to that here. Right now, it's just set on the HSM configuration. All the calibration factors would be 1, but if the agency has factors, we can point to that here. Same thing with crash distributions and the model. So if the state has developed their own models and input that in IHSDM, they can access that through here. We have the first and last year of analyses. So in this case, it's 2020 to 2040. We can select whether we want to apply crash history data as part of an empirical Bayes analysis, either none, meaning either we don't have the crash data or it's not applicable to this case, or yes, we want to do site specific. And of course, we have the data here, and that's what we'd like to do. So again, our starting and ending years for the crash data, 2015 to 2017. So here on the next screen, we see the crash data that's been input. We could modify this here, or we could just accept it and go ahead. And again, here's telling us the number of crashes we have per year. Those are the observed crashes. So we'll run that, and that produces an evaluation report. And stepping through this, there's a report overview. This shows the number of observed crashes that we've input. So this top part is just reflecting what's input. So we have 22 observed crashes, and all those crashes will be used in the evaluation as part of the empirical Bayes process. We are evaluating one intersection. It's an urban suburban arterial intersection with 4 legs, and it's signalized. We show the ADTs for the major and minor roads here. And then again, parroting back the data that we've input. So a number of approaches with left turn lanes, with right turn lanes, and so on. So we scroll down, then we have a summary table for this particular intersection with these conditions. It's expected that we would have 118.3 crashes over that 21-year period. And then there's also a breakdown by fatal and injury and property damage only crashes. If we scroll down a little more, we see the breakdown by year. So we have for each year, because our ADTs did not change, those values are the same year by year. If our ADTs changed, you would see those values change. So these are the predicted crashes. So that's just using the model itself, and then the expected crashes, which is factoring in the historical crash data. We see those results, and those are what total up to 118. There's also a breakdown by crash type. This is a default distribution that's applied, and that can all be useful in some cases. So that's looking at the existing. So that's the existing with not considering the additional site traffic. So what about if we add site traffic? So now looking at the impact of adding those adding the traffic. So here's looking at the so this is the no build, but with the site traffic generated by the proposed development, the additional traffic. So now we've gone from 118 up to almost 130. Okay, so that's the additional crashes that we can expect just from that proposed development over 21 years without any type of countermeasures applied. Okay, but we did see that we did indeed have countermeasures that were proposed for this particular project. So we for the alternative one, you may recall that there are countermeasures that are proposed that are not part of the HSM Part C model. So here's where our user-defined CMF will come in. And want to go to we have the CMF clearinghouse just to show you how we would search. We happen to know that for this project, we were looking at 2 CMFs. So one was CMF 8790. That was one that was identified for installing pedestrian countdown timers. So I had done a search for that, and here's our CMF from the clearinghouse. We of course want to make very sure that this actually is applicable to our conditions. So first we see here that it's a 4-star study, which is good. It's very good. Highest rating would be 5 stars. This is a 4-star rated study. 0.912 is the crash modification factor value. And then if we scroll down here, we see it applies to all crash types, all crash severities. It's applicable for roadways with 2 to 6 lanes, speed limits of 30 to 55. And there's down at the bottom here, there's ADT ranges, and our project is within those ranges. So it seems like this is a good fit for our project. We were also looking at adding 3-inch yellow retroreflective sheeting to the signal back plates, and that has a value of 0.85. So I won't spend the time to look at it here, but this also applies well to our project. So we have the 2 crash modification factors now that we'd like to apply to this project. So going to go in and we have what's called the concept of versions for the highway and or the intersection. And in this case, that's sort of allowing us to take a snapshot of the project and to come back to it at a certain time if we'd like to make that active. So we have two versions. One is the existing, and then one has these countermeasure CMFs added. So here's version 2 of our highway, and I've already entered this data. So here's the user-defined CMF. So we're saying it's composite user-defined CMF. It includes the installation of pedestrian countdown timer and the retroreflective backplate. We could apply this only to certain years of our study, but if we wanted to all years, we would just leave the start year and end year blank. Severity can be applied total, fatal and injury, or property damage only. We'll say total. And then there's our 0.78 CMF value. Okay, so we're all set now. So we have now, if we evaluate this condition, then we would see the impact of the improvements to this site. So let's go ahead and open this report. Okay, so now you may recall that without the improvements, we had close to 130 crashes over this period, and now applying the improvements for, this is alternative 1. So with all the improvements applied, that's reduced the crashes to 115.78. Okay, so that's for alternative 1. Now for alternative 2, again, you might recall that alternative 2 includes the improvements that were identified for alternative 1, plus there were a couple of other measures to reduce crashes. So one of those was to add a right turn lane in the southbound direction of Main Street. As you saw in the build, as we saw before, we have that additional right turn lane here. And then the other thing we did was we looked at the intersection, and for this case, the left turn phasing is now protected permissive on Smith Road instead of just permissive. Okay, so we have with those modifications, then well, first, with just those modifications and not applying those user-defined CMFs, we can see we've reduced the crashes to just about 120. So in alternative 1 and in the no build with the site traffic, this was close to 130. So we've essentially reduced it from 130 to 120. Now we'd like to apply those the other countermeasures, the user-defined CMFs for the pedestrian treatment, as well as the retroreflective backplate. Okay, so now you see that reduced to 105.5. So now we have all of the information that we need. We've evaluated all of our cases, and the next step would be to take these results and to apply those in the economic analyses tool. Okay, so I'm going to pass this over to Ehsan, and he will illustrate how to use these results in the economic analysis.
Thank you, Mike. So as Mike mentioned, so we do have the CPM results, crash predictions. But before I go ahead with the economic analysis, I just want to mention that IHSDM is not an online tool, which I and Mike are not currently working on the same project, but we can share the files and then work on the same project, but not at the same time. So to run an economic analysis, again, like IHSDM itself, we need first to create a new EA project. So let's name it TIA plus DDSA. And then we need to add those crash predictions for this economic analysis. So let's name it like future no build. And then since we want to consider this one as a base for comparison with the two alternatives that we select this one as a base, and then we add those crash prediction results here. So we will select that particular, so IHSDM application TIA case study, and then we will select that particular crash prediction result. So future no build, no site traffic, but not this one, but no build alternative one. And then we have no build crash prediction result and no CMF. So then we will use calculate crash cost. So the calculation is based on converting the CPM result to KABCO scale and using those crash costs that Mike explained to get this value. So then hit OK. And since this is the no build, and by no build, I mean the facility is going to be constructed, but there is no treatment regarding the safety. So the cost, associated cost is 0. So this is the base condition for us. And then I will add the alternative 1 treatment crash prediction result and second. So this one, let's name it alternative 1. And since this is not the base case, I will not check this box. And then I will add again. So same actually project. So, and then I will select the associated crash prediction. So this is for future, but then this time I will select alternative 1 with the user-defined CMF, and then I calculate crash cost. So as you see, due to those treatments, the total crash cost decrease. But then for this one, let's assume as it's also in the how-to guide, so $115,000 as the cost. And let's add the other alternative. So alternative 2, again, this is not the base case, and also let's find that particular CPM. So then we will select the analysis. So alternative 2, and then again with user-defined CMF. And so calculating cost. So this one also again showed some reduction, but let's say the cost to implement this alternative is $150K. Okay, so as you see now, we have all 3 different alternatives, no build, and then alternative 1 and 2. So then you have the option either to update or save. Save will create a new version, but let's go with update. And then you close this one because you have all CPM results, but then we will run an EA analysis. So let's name it, but we can go with the default, and then we have the benefit cost analysis. And in the summary, so we have all 3 alternatives, and make sure this box is checked, and then we run the evaluation. So in the evaluation output, at the beginning, we have some configuration summary. So those costs associated with different severity level, but then this can be modified depending on the differences, values that being used in different jurisdictions. And then these are just to calculate these tables for different FI, but then here the output summary. So for the future no build, the present value of crash cost is 7.6 million, but then alternative 1 and 2, depending on using those treatments, decrease the crash cost. And also we do have the present value of the cost for implementing those 2 alternatives, and eventually we can calculate the benefit cost ratio. So for first alternative, is 9.1, but for the second one, since it decreases, crashes more, we do have 11.7 as a benefit cost ratio. And also we have the crash summary by KABCO scale, which is the basis for these calculations. Also, I would like to go back to IHSDM in the project that Mike mentioned. So these items with a different icon in the project tree. So these are location based. So just let me open one of them. So maybe this one. So these are like in a tabular spreadsheet format. So instead of having different editors and also visually seeing what the project looks like in the highway viewer, but here we have them in the table format. So for example, for this scenario, which is future, no side traffic, no bid, then we have the characteristics of that condition and added for like a spreadsheet format. But then we do have traffic data and also historical crash data. So it's like spreadsheet, but depending on the project, that may give the opportunity to actually handle cases depending on the need. If it's small size, you may use this one, but a large size or required segmentation, you can. But also in the site set format, also the version history can be used. So as you see on the same file, we can have different cases. So just let me open another one with one of those user-defined CMFs. And then when we get back to the edit side for that particular location, we see that the user-defined CMF also can be added. This kind of similar format, the same concept, like location-based. Now let me get back to the slides. So to summarize the demonstration, so for this case study, we had some treatments that in two different alternatives, but for installation of crosswalk, since there was not a good quality CMF, so it was not applied, even though it was in two different alternatives. But then for the two treatments of installing pedestrian countdown timer and also backplates, which were in two alternatives, we use user-defined CMS from CMF clearinghouse. But then again, for optimizing signals, they were not accounted. But for the two treatments for alternative 2, since part C CMFs could handle and they were accounting for those changes, so they were modeled. So there was no need to add additional CMFs. But to look at the summary of the economic analysis, again, as I showed, alternative 1 is resulting in 9.1 benefit cost, but alternative 2, 11.7. And just to look at what actually happened for the crashes for no bid, it was 129. But for alternative 1, prior to applying the composite CMF, again, similar, because those changes were captured by the user-defined CMF. So applying those user-defined CMFs resulted in 115, so 14.1 crash reduction. But for alternative 2, since some of the changes captured in the CPM, so 119 was the crash prediction prior to composite CMF application, but then applying that composite resulted to 105. And then in terms of the percent reduction, 10.8% reduction by alternative 1, but 18.8 by alternative 2. And then again, looking at a kind of summary table, so alternative 2 produces better benefit cost ratio and is selected. Now I will pass again to Dave to wrap up. Thank you.
All right, thank you, Asan. So I'm going to share my screen here. Hopefully that's coming through all right. If I'm all right, if I'm not all right, somebody let me know. But I want to wrap things up. Before doing so, I'd like to just mention again, I said that our how-to guide, which is the basis for this demonstration and the case study really, it's limited. It doesn't describe quite a bit, and it makes a few assumptions. One of the assumptions that I wanted to point out was what scenario is the base case versus not the base case. And it was intended to demonstrate the role of DDSA in the traffic impact study process. The demonstration that Mike and Asan just ran through shows how the future build scenario with the addition of site-related traffic was a base case for calculation of, say, effectiveness. That's not necessarily the base case that would be appropriate for you or for your project. Typically, with transportation impact analysis, the future no build without site development traffic is viewed as the benchmark or the datum or the base case by which then you then start measuring and evaluating impacts. I just wanted to point that out. So let's wrap things up, everybody. I want to put out another poll question. So Carolyn, if you wouldn't mind, I'm not going to bias you in any way. I'm not going to give you any background, but we'd like you to answer and participate in this poll question. Should traffic impact analysis and related studies include a commensurate data-driven safety analysis? Without thinking too hard about it, please participate in this poll. And let's leave this open, Carolyn, until we get a good number of our 44 participants responding. All right, Carolyn, how are we looking on responses? If we have a good number in, we could consider wrapping the poll up in about 5 or 10 seconds.
Yep.
All right, wonderful.
Answer.
Great, let's go ahead and we've got good response. Let's close it and show you the results, what your fellow attendees have had to say. All right, so we've got a number of you, almost all of you, not saying no, safety should not be addressed, or no, safety DDSA shouldn't be included, but at least recognized in some way. Instead, I see most of the answers are yes in all cases, or yes only in certain cases. And the two stratifications there that we gave was yes, but only when the project has some characteristic or generates a certain number of trips. The other yes is but only in cases where there's a known issue within the study area already in I guess, in existing conditions. So this is great. Thank you for participating in this poll. And it is somewhat reassuring to see that nobody said no outright. That's good. We've done part of our job here, everybody, in that way. So thank you for participating. So let's be honest, this is not easy, and questions are definitely remain in my mind, and I realize in yours as well. And some of those questions could include these. What's the appropriate scale and scope of a safety analysis? We got to figure that out for operations. How about for safety? And how would you define an impact? We'd have to do that for operations. How would we do that for safety? And what if one area benefits while the other experiences a disbenefit? That's absolutely possible and very likely in many cases. These are questions for which I am not suggesting I have an answer. What happens if we use DDSA? What happens if we don't? What are the consequences for action and or inaction? And how would these results be used? How would they be meaningful? And would it be cost effective? I think it's honest and upfront that additional work in a traffic impact study would require additional time. So would it be effective from the perspective of those reviewing and preparing TIAs? Would be effective on part of the taxpayer and the traveling public and our stakeholders and local and county government and in the private sector and the development community to focus on safety analysis? Great questions. There are some challenges that go along with these questions that I wanted to mention as well. You know, in operations, we focus on vehicles per hour as the primary exposure metric, but in safety analysis, you'll notice a lot of those safety performance functions depend on annual average daily traffic. There are a lot of great resources out there on converting between one and the other. For example, the ITE trip generation manual now includes more equations on daily traffic as opposed to just peak hour traffic than it has in the past. But how acceptable would crash prediction and safety performance functions be? They're relatively new. The highway capacity manual, it's been around for 60 plus years. And if we can look at it and note very early that the highway capacity manual, despite being much older, has still a great number of limitations, a lot of conditions for which we don't have a printed equation. And that's why a lot of people end up resorting to microscopic simulation. So what's the maturity and acceptance of these models? And yeah, it's going to take additional time to do more analysis. Now, another, I think, specific challenge is that a lot of area-wide pro rata share districts, improvement districts, for example, in Pennsylvania, you have the Act 209, which are based on delay impacts. And these are not at all directly related to safety. So what if one of these studies are in place and they don't include safety, or at least not directly, and are based on changes in control delay through some HCM-based analysis effort? That's a particular challenge. I think another one that's really important is a lot of traffic impact studies deliberately and expressly have very limited study areas, traditionally just focusing in at the nearby intersection. The bigger the study area, the more the expense, the more effort is required. And as a result, smaller study areas may not truly capture volume diversions that can happen, especially with larger development projects. And if we divert volumes from older, more challenging roadway environments to newer, better engineered roadway developments, that's an experience that hopefully would be captured in our safety analysis. But traditional TIAs are a bit of a challenge with respect to that. And we also do have rather compelling obligations regarding safety that make this a particular challenge. A political discussion, a professional discussion is absolutely underway. And if you're not aware, there's a lot of change right now within the Institute of Transportation Engineers, the producer, if you will, of a lot of the great material that are used in the world of traffic impact studies. And that's another consideration and challenge. But generally speaking, we do know that the science tells us that when we add traffic volumes, this is generally speaking, or add access or increase the number of conflict points at an intersection, that translates to more crashes. Those are challenges, I think. But all the while, there are some benefits that I wanted to leave you with. We do have the opportunity by using DDSA to mitigate existing and future safety performance issues and take into account the ability to have better access, especially for vulnerable road users. And you know, we have in many states throughout the nation, intersection control evaluation policies already in place, including in Pennsylvania. So that's a great example of where on an intersection basis, safety and operations are coming together. Now, risk factors, target crash types from systemic safety, and even the application of local road safety plans could help with localized impact studies. Imagine if a local road safety plan or a township or borough's comprehensive plan said that we got to target pedestrian crashes. They're a particular problem, or roadway departure or intersection crashes. And our localized study area was looking at just those crash types. That could be a great tool or asset for TIAs. What I wanted to mention and be keen to mention was that states are setting performance targets for all public roadways. In accordance with the FAST Act, MAP 21, all public roadways are having these safety targets being set, including many roadways that are touched by traditional traffic impact studies. So we've got an opportunity there to be part of the grander, the bigger picture, if you will. And I think a lot of the methods that we have in predictive safety cover conditions that we encounter in TIAs. There's going to be limitations, but we have models now that we didn't have before that can help. And we have the benefit also of a lot of great resources and guidance out there. And we do know that all our clients, our stakeholders, want good, safe, reasonable access. It's part of economic development. It's part of community development, and it just makes good sense. So to leave you with this note, the safety performance targets that I mentioned are pretty diverse. You can see the 5 here that are coming through the SPM target setting efforts, and talk to your friends at PennDOT or your local MPOs if you're interested in learning a bit more. But these are targets applicable to all public roadways. So the final vision is not just for all projects, but hopefully for all projects, including those developed through traffic impact studies, we can realize a vision where data-driven safety analysis has a role. The traveling public doesn't distinguish between a lane widening project done by a capital job versus one funded by a developer. And perhaps there's an opportunity there for data-driven safety analysis to be part of all projects. So with that, I wanted to ask you guys to participate in our final poll question. Are you interested in more in-depth training and/or examples on the incorporation of data-driven safety analysis? If yes, please let us know. If no, or maybe, feel free to participate. So I want to wrap up with this poll here. Please participate. All right, Carolyn, if we've got a good yay, nay, or maybe from everybody, let's maybe close the poll in a couple seconds and then display the results. Wonderful. Let's see what everybody had to say. Yes, maybe, not sure. And just one of you said, nah, forget it. All right, great. Thank you for participating in that poll. We can go ahead and close that out. That's helpful for us. So we have some training opportunities. For more information, please feel free to visit the IHSDM site to download the tool, learn more about it. We have some ongoing training opportunities that are about IHSDM, and also some newer tools available. And I believe we'll be making a PDF of the slide deck available to you. But if you're interested in more in-depth training on IHSDM, not just how it could be applied in traffic impact analysis, please do feel free to reach out to me or to visit the NHI website. We also have 2 courses that are piloting this year, and this is a selfish plug. If you're interested in being part of a pilot for a new web-based course on IHSDM or a new web-based course on data-driven safety analysis, please do send me an email at david.petrucci@dot.com. We also have a user group that's been organized to facilitate discussion with our users, and that's between Federal Highway staff and us. Please get active. The IHSDM.org site is a great way to get connected with that group. And with that, I realize we're at scheduled end time, but if there are any questions, we can stick around for a minute or two before you move on. I'm going to take a look at the question and answer pod. We're happy to stick around for a bit, but any future discussions, please feel free to put them in the chat pod. Oh, I do see that there are a number of questions here that we don't have an answer for yet. Andy, I see you typed in a question. Why would a new development which is not yet generated a single trip be responsible to correct an existing safety issue? Great question, Andy, and I don't know. We're talking explicitly about the capabilities of the tools and the science that's captured by these tools. How and when you and your clients choose to use these tools, that's totally up to you. Instead, we're focusing on what's technically available. Another question is, although alcohol sales establishments are involved, what alcohol sales establishments are involved? What about impaired driving? Yeah, impaired driving, I'm sure, is captured by a lot of the models that are captured by IHSDM, and including the sales establishments numbers factor, which goes into the calculation or estimation of pedestrian crashes at urban suburban intersections. But yeah, they are built in there. There's another question about how often are the costs for severity updated? Great question. Not often. The National Highway Safety Manual has crash costs that are rather old. Federal Highway has a newer how-to guide that put out newer research and provides newer estimates on unit crash costs. And that came out just within the last couple of years. Those are the default values that are now in IHSDM. Let's see, are there any other questions? Mike, Mohammed, any comments that you'd like to make before we wrap up? Anything that we did not address?
No, I do not have any further comments. Thanks, Dave. I think we almost covered everything.
Dave, don't have any other comments. Just want to thank everybody for participating and hope that you enjoy the conference, which is just starting. Enjoy the next few days.
Great. Thank you, everyone. Much appreciated. It's been a pleasure. Enjoy the conference.